Hello, everybody. Today I'm going to talk about some chemistry calculations. It's called chemistry. It's called stoichiometry. What this word means is you have a chemical reaction and we want to do some calculations. Let's have an example. This is a reaction equation. Aluminum and bromide. Aluminum and bromine create aluminum bromide. Our question is, I want to produce 5 mole of aluminum bromide. How many moles of bromine do I need? So this is a question. So how do we do it? You write the 3 below the x. You write this 2 below this 5. Do a ratio x over 3 and write a ratio 5 over 2 and make them equal. Okay, let's erase the moles and mole. Now we have an equation. X over 3 is equal to 5 over 2. And x is what we want to find. Solve this equation. You know how to solve it. Maybe you will say cross multiply. 2 times x is 3 times 5. But let's do it even simpler way. So move the 3 to this place and you multiply the 5. So I move the 3 to this and multiply the 5. X is equal to this. 3 times 5 divided by 2 is 15 divided by 2. What is it? 15 divided by 2 is 3.5. 7.5. How many moles of bromine do I need? 7.5 moles. I need that. So it's a very simple calculation. Just do the ratio and solve for the unknown. Let's have another example. I need to write this smaller because I have another term. Sorry for that. Oh, it's not right. Still not good. Huh? Okay. All right, the question is, okay, this is the chemical reaction of, we must balance it before we can do calculation, okay, balance. It's a balanced chemical reaction. So the question is, how many moles do I need for the oxygen? It's how many moles, okay. And I have 1.2 mole of, this is ammonia. I have 1.2 mole of ammonia. Then how many moles of oxygen do I need to react with this much ammonia? This is how many moles? How many moles of this? Similar to what we have done for the first example, write the 2 below this. Write the 3 below this. And write the ratio. Let's erase the unit. Let the 2 ratios equal to each other. Solve for x. The x, to solve for x, you move the 3 to here and multiply. So let me erase the 3 and multiply. X is this much. So x is what? Just use your calculator. 3 times this divided by 2. And then it is 1.8. So you need 1.8 moles of oxygen to react completely with 1.2 moles of ammonia. For this same question, we have another part. This is to find how many waters will be generated. Okay, let's erase this. This is part B of this question. How many moles of water we will generate? How many moles of water we will generate if we want to produce 12.5 moles of hydrogen cyanide. This is cyanide, this is hydrogen cyanide. I want 12.5 mole of this much, then how many moles of water do I need? Okay? So this is part B of this question. If I want to produce 12.5 moles of hydrogen cyanide, then how many moles of water should match that? Maybe I should say it in another way. In this reaction, if I want to produce 12.5 mole of hydrogen cyanide, then at the same time, how many moles of water will be produced? Similar to what we have done so far, put the 2 below this, put the 6 below that, below x, do a ratio, let them equal to each other, solve for x. How do we solve for x? Move the 6 to here and multiply. Use your calculator to do this calculation. So what is x? Then x is so this is how many moles you can produce. How many moles of water you can produce in this reaction. So it's a ratio problem. So that is for this, part A and part B. Let's do another example. Okay. This chemical reaction, what do we have? We have 13.9 moles of ethane. This is mole, okay? Mole of ethane. And I want to find how many moles of oxygen can react completely with this much to produce carbon dioxide and water. So I need to find how many oxygens, how many moles of oxygens. Yeah. And let me erase the mole. Everything is in mole, okay? Everything is in mole. What is X? How many moles of oxygen do I need to react completely with 13.9 ethane? All right. Just like what we have done before, write the 7 below X, write the 2 below 13.9, write the ratio, and let them equal to each other. So what is X? Move the 7 to this side and multiply. So X is equal to, just use your calculator, X is equal to 48, use the calculator, 48 65. Okay, we can run it. So let's write 7. Okay. So I need oxygen. How many moles of oxygen? 48.7 moles of oxygen. Okay, I have another part B. Okay. I have part B is how many moles of water will I produce? How many moles of water will I produce if I have 1.4 moles of oxygen there? I have 1.4 moles of oxygen there and react with ethane. How many moles of water will I produce? Same as before, write the 7 below 1.4 to the ratio, write the 6 below x to the ratio, and let these two quantities equal to each other. So what is x? You just use your calculator to solve for x, all right? Use your calculator to solve for x, and move the 6 to the numerator, and you multiply. Okay. How many moles of water I will produce if I have 1.4 moles of oxygen? So x over 6 is equal to 1.4/7. Solve for x, move the 6 to this side and multiply. Use your calculator, and x is equal to use your calculator, solve for x equals to 1.2. So how many moles of water will be produced? 1.2 moles will be produced in this reaction. That's part B of this example. All right. Let's have another example. Magnesium nitride Okay, this is the reaction equation. I have magnesium nitride react with water. I have magnesium hydroxide and ammonia. All right, so what is the question? The question is this. I have 2.3 moles of magnesium nitride, and I want to find how many, in this example, it's not how many moles, it's how many molecules of water do I need to react with 2.3 mole. So this is 2.3 is mole, and this is how many molecules do I need? X is how many molecules? To do this question, let's do it in 2 steps. Do not find how many molecules, find how many moles. Because this is what we have been doing for the last few examples. Everything is in mole and it's very easy to solve. So let's forget about the number of molecules. Let's find how many moles of water will react with 2.3 mole of magnesium nitride. So let's do moles first. Yeah, erase the mole. Everything is in mole. So this is 1, so 2.3 over 1. This is x over 6. And let them equal to each other. Then x is 6 times 2.3. So this is just 6 times, this is 13.8 mole. I need 13.8 moles of water to react with 2.3 magnesium hydride, nitride. But the question does not want to find how many moles. The question is to find how many molecules of water. How do we do that? So we need to change mole to molecule. Now, this is what we want to remember. 1 mole contains 6.02 molecules. 1 mole contains 6.02 molecules. Now I have 13.8 moles. So how many molecules are there? So I need to multiply this by 6.02 times 10 to the 23. Oh, I said something wrong. I said 1 mole contains 6.02 molecules. That's not true. 1 mole contains 6.02 times 10 to the 23rd power. This number, this many molecules is in 1 mole. So you multiply this, and then the x is equal to, in terms of number of moles, x equals to so you get the answer. This is the answer. This is the number of moles. So you can shift the decimal point and you get 8.31 times 10 to the 24 number of moles. This is, not number of moles, sorry. This is number of molecules. Okay. This is number of mole. You multiply this factor, you get number of molecules. 1 mole contains 6.02 times 10 to the 23 power. That's a converging factor, okay? So this is how you find the number of molecules. Let me repeat this. To find the number of molecules, you find the number of moles first, because that is very easy to find, number of moles. And once you have the number of moles, then find the number of molecules. Okay. There is another part B of this question, of this example. Part B of this example is It's still 2.3 mole of magnesium nitride. It is still 2.3 mole. But I want to find how many magnesium hydroxide will be produced. How many what? It's not how many mole, but I want to find how many molecules of magnesium hydroxide will be produced. Just like part A, instead of finding how many molecules, I want to find how many moles first, and then change the number of moles to number of molecules. So, do moles first. So this is 1, so 2.3 divided by 1, x divided by this 3, and let them equal to each other. Then I have move the 3 to this side and multiply 3. So divide by 1, you don't need to divide by 1. So this is x equals this much mole. And then I need to change mole to number of molecule. So I multiply this whole thing by 6.02 times 10 to the 23. So that is how you find the number of molecules. Then the answer, final answer is x is equal to 4.15 times 10 to the 24. Or you can round it to 4.2. That is just not important in our calculation. Rounding is the final step. So this is the number of molecules. So let's make a summary. To find the number of molecules, you find the number of moles first. Find the number of moles. That's the number of moles. Once you have the number of moles, multiply this factor, you get number of molecules. So today I have shown you how to do some calculations in chemical reactions, but this is only for moles. Everything is in mole, but sometimes suppose we want to find number of molecules, then we find the moles first and then convert it to number of molecules by multiplying the number of moles by this factor. You multiply the number of moles by this factor, then you change it to number of molecules. Okay? That's today's lesson. Thank you for watching. Goodbye.